Okay, so this is going to be your first question. So there are 5 questions. You will be pausing the video, doing them, and then run through them. So these are typical questions that you're going to get in your physics exam. And today we're just going over 5 principles. So question 1 says, state the principle of moments, and is a 3 marker question. So I'd like you to pause the video and try question 1. Pause the video and try question 1. Okay, so I hope that you pause the video and you tried question 1. So before I show you the answer, suppose that I've got a rod or a ruler and I support the ruler with a pivot at this point here. Now, if I apply a force, I push the ruler down, for example, with a force of 10 newtons at that point, and the perpendicular distance from where the force is to the pivot, suppose this one is 20 centimeters, okay? Then I can work out the turning effect of this force. And the turning effect of a force is normally called a moment. And the moment is always equal to force times by the perpendicular distance. In this case, the force is 10 newtons and the distance is 0.2 meters. Now, in physics, when you are talking about length, you should always convert the length into meters, is the standard SI unit. So if you do 10 times by 0.2, the answer is going to be 10 Newton meter. That is the moment due to this force. So the turning effect of a force is called moment. Now, when we talk about the principle of moments, the idea is that if something is in equilibrium, is balanced, then the clockwise moments and the anti-clockwise moments will always be equal. So say, for example, here, the distance here is, say, for example, 10 centimeters. And we've got another force this side. And this force, I don't know what it is. I'm going to call it P. The idea about principal moment is that when these two substances are in equilibrium, the weight and that weight there, then the clockwise moment, which is 10 times by the 20, should be equal to the anti-clockwise moment. This is going to spin anti-clockwise, and that'll be force times by the length, which is 0.1. So they should be equal. And in this case, then I can find what P is by timesing 10 by 0.2, which is this side, then dividing by 0.1 this side, and that'll give me the answer to that. So when you talk about the principle of moments, you must be able to define it with understanding. So the principle of moments states that for a body in equilibrium, the sum of the clockwise moments about any point is equal to the sum of the anti-clockwise moments about the same point. That is the definition. So sometimes I could have one force here and another one that side, and I could have another one this side. All right. So what we are saying is that the sum of these two, because this will go clockwise like that, and this will go the anti-clockwise, the moment due to this force and due to that force added together should be equal to the moment due to the other force if they are in equilibrium. That's the principle. So if you got that, give yourself 3 marks. If you didn't get it, please pause the video and copy the answer down. Now we go to question 2. Question 2 is on force equals mass times acceleration. So I'd like you to pause this question 2 and then try it. Use G, gravity, due to acceleration to gravity as 10 meters per square second. Pause the video and do that now. Okay, so I hope that you pause the video and try this. Now, when we talk about the net force acting on an object. Let's say this is a box, and this box has got a weight pulling it down of 10 newtons. All right, there will be another force that would be balancing it going up, called normal reaction, if this is on the floor resting. Okay, now if I pull the box with a force, suppose a force of 20 newtons this side, and there is frictional force that is opposing that, a force of 20 newtons, then this box will have zero acceleration. If it was stationary, it will stay stationary. If it was in motion before, it will carry on at exactly the same speed. Because the forces are balanced, the acceleration is going to be zero. So the net force, if I think about the forward motion, positive, then the net force is going to be zero. Because the 20 that's going forward, this one, and the other 20, this will now be negative because it is going the opposite direction. So the net force in the horizontal sense will be zero. What about if this was removed and there was no force now? Vertically, there is no net force. I can just remove that. But horizontally, the net force now is 20, take away 0. Because there's no force opposing it. It's as if there's no friction, it's smooth. So the net force is 20. However, sometimes you could have some little force in play. So say, for example, I've got a force of 12 newtons there. Now, the net force is going to be 20 take away 12, and that's going to be 8 newtons. Do you see this? Now, the net force in question will affect what we call the acceleration. The higher the net force, the higher is going to be the acceleration, isn't it? So we normally say that F is equals to ma. And what that means is that the net force that you're going to put on an object to make it move will depend on how big it is, the mass, and the acceleration that is needed. The higher the acceleration needed, the more force you're going to have to put there. The heavier it is, the more force you're going to put there. So you can look at it like that. So I can use this formula to help me work out this question. What are they asking? The acceleration. So I'm going to make x in the subject, and that's going to be equals to force divided by the mass. The force is in newtons already, okay? And the mass is going to be 2 kilogram. Okay, he says a body of mass 2 kilogram is acted upon by z force of that, work out the acceleration. So we have 3 newtons per kilogram, but we're not going to use newton per kilogram here because its acceleration is not, this is not gravity, is acceleration. So we're going to use meters per square second. We're going to use meters per square second. So that is it. So it's force divided by the mass, and that will give us that. Now, they say that use G to be 10. In this case, we don't actually need that unless we wanted to work out the weight. So the answer is just that. Now, they say this is 4 marks. Personally, I would give not more than 2 marks on this. I will not give more than 2 marks on this. Okay, now we got the next question. It says a balloon is filled with hydrogen gas and is then released. It rises up in the air. Explain this observation, and it's 3 marks. So I want you to pause the video and try this. Okay, so I hope that you pause the video and try this. Now let's understand something. I put a balloon here. The balloon has got this gas, hydrogen gas. Hydrogen gas has got very low density. It's a very light gas. Underneath here, I'll be having air particles bombarding it from all directions. There will be air particles bombarding it from all directions. And in fact, even at the top. But because it's less dense, it means that the weight that is due to it. So let's, for example, the weight is 2 newtons, would be less than the way the forces that these air particles are exerting on it. So that would be more, probably let's say 10. So you see that the net force acting on it is 8. 10 take away 2 is 8 going up. Because of that, the balloon is going to do what? To rise up. Because the forces that are exerted on it from the bottom, called upthrust, will be more than the weight. Alright? Alright, so I want you to pause the video and then mark this. Okay, so I hope that you pause the video and you marked it. Now we're going to go to the next question, which is question 4. Now question 4, the answers. So I'm going to do that right in front of you and make sure you don't look at it. Okay. Right, so this is question 4. I'd like you to pause the video now and do question 4. Question 4 is on electricity. Question 4 is on electricity. Okay, so I hope that you've tried question 4. So the first thing with this, you can draw a circuit. And I'm going to draw the circuit of a cell, though battery should know this is just, I'm going to use cell to just make things easier and quicker. And then I've got a series circuit, which means there's only one pathway for the 3 resistors. Now, I'm going to use a lamp as a resistor here, and another one, and another one. So I'm going to use these lamps to represent the resistances that I will get here, because anything that uses energy is a resistor. Could be a fixed resistor, could be a lamp, could be anything. Now, they've got different resistances. One of them has got 5 ohms resistance, and this one is 3 ohms, and this one is 2 ohms. All right. Now, what that means that the one that has high resistance takes more energy. As the electrons are going through the wire, they are transferring energy to these resistances. So the 5 one is going to take more energy. So this one is going, the 5 ohms one will take more energy. Okay. That's going to take more energy. Now, but the question says, work out the total resistance. In a series circuit, the total resistance, I'm going to say RT, is the resistance in the first resistor plus resistance in the second one, and so on. Okay? And so on. In a series circuit, you just add them. So we do 5 plus 3 plus 10 plus 2, and that will give us 10 ohms. Okay? That's our resistance. Now, they've also asked us to work out the current. So if I had an ammeter, let's say I had an ammeter put there, what would be the reading if the potential difference applied by the power supply is 12V? All right. Remember, resistance is always equals to V over I. Okay. And if I want to find I will now rearrange this, and that will give me V over R. The total potential difference is 12V, and the total resistance is 10 ohms. If you do this, it's going to be 1.2, and the unit for the current is always amps. So 1.2 amps. This is it. Okay. Right. So I hope that makes sense. So I would like you now to mark it. If you got 10 ohms, one tick. Could give yourself 2 ticks on that and 2 on this one. Though this question, personally, I would give it 2 marks at the most, or 3 at the most, because it's not very hard. Now we're going to do the last question. And this is the last question. The last question says, describe an experiment to measure the density of an irregular solid using a spring balance and a measuring cylinder. I'd like you to pause this video and try this. The diagram I've put here is not necessarily the diagram that you need to answer the question, but it's just to help you visualize it. So pause the video and try this. Remember, this is describing an experiment, and it's a 6-marker question. You want to write your steps very well. Pause the video and try this. Okay, so I hope that you've tried this. Now, when you get an experiment question in physics, the first thing, think about the calculation that you're going to do. The density. And think about the formula that you need. In this case, it's mass and volume. Then, describe how you're going to measure the mass of the object and how you're going to measure the volume. What equipment you're going to use and how you're going to measure that, and your calculation, and maybe a table you're going to design it. Do you see this? So in this case now, the irregular object, suppose is this. Let's say is irregular. This one looks regular, which means we can use formula to work it out. But let's just say it's regular. It's irregular. We just need to work the mass. What are we going to do? Use spring balance to measure the weight and change that to mass. Okay? The next thing, you could use this measuring cylinder only, or you can also use this can as well. So the idea is that you fill this can to this point here. All right, to the point. Should always fill it to this level. where there is like an opening, a sprouting. Now, when you dip the stone or whatever is, the water level will try to rise, and as it rises, it will spill into the measuring cylinder. And then you take a reading of how much that is, and that's going to be the volume. Alternatively, you can just, if it is a big measuring cylinder and the object is not too big, you can put it inside that measuring cylinder, having the initial level of water somewhere that you know, let's say at 10 centimeters cubed, put that stone in and see how much it goes up. Let's say it goes up to 18 or something. The difference will be the volume, all right? Then you just put that in your calculator, and then that will then give you the answer. So I'd like you to pause the video and mark your work. If not, you copy this down. Okay, so I hope that you pause the video and you marked it. Now we stop there. Before we stop there, I want you to do 3 things. The first thing I want you to do, I would like you to subscribe to these videos. If you find them useful, please subscribe. We normally upload so many videos, not just physics. We do maths, we do secondary, we do primary, we do English, we do all of them. So subscribe. So when we upload a video, you'll be able to be notified. The other thing, I would like you to share this to your friends, as many as you can share in your WhatsApp. Please share that and then click like, and I would really appreciate that. So subscribe, share, and like. Thank you so much for now. Thank you.